Okay, next up, it's Thomas Harper, who is going to tell us a little bit about how they use ZIO and Scala 3 at Wolt. Take it away, Thomas!
So first I have to manage expectations. So I used to be involved in the Haskell community a lot, and there was a very famous Oleg Kiselyov, who was famous for his mind-blowing type theory lectures, and this seems to be something that Olegs do in general. I'm not going to blow your mind with type theory, just so you know. This is going to be a bit more of a pragmatic talk, I would say. And also they made me put a lot of buzzwords in my title, but I'm mostly just going to tell you about ZIO and not very much about Scala 3 specifically, although we do use Scala 3. So yeah, my name is Thomas Harper. I'm a staff engineer at Wolt. We use, among other languages, Scala quite a lot there. So I'm going to tell you a bit about how we build microservices, at least in my part of Wolt. You can go to the next slide. I don't know who'd go. I control it. Great. So first, I don't know. I promised I would not market my company too much, but I have to tell you what Wolt is in case you don't know. So we are a food delivery company. Unfortunately, in Sweden, you might be more familiar with Foodora for now. But we do deliver food and from other merchants as well to your home via an app. So yes, to give you an idea of our scale, this is not so much for how great we are as a company, but to give you an idea of our scale engineering-wise. So maybe you want to think about we're in 27 countries. We have 36 million registered users. 140,000 merchant partners and 230,000 courier partners. So I wouldn't say we're like internet scale, but we have a decent amount of traffic. I work specifically in the Courier Group, which I'm going to tell you about. So when you want to think about the scale of the services, how many people use them, what kind of traffic goes through them, we're talking in the hundreds of thousands of users. And to give you an idea, also just contextually, hopefully you have seen our customer app and you like using it. We also have two other apps that you're probably not familiar with. So one is the one that couriers use, and one is the one that merchants use. This is also just to give you an idea about the language community. So these are almost completely autonomous teams, both in the front end and the back end that use them. So I'm going to talk a bit about what my team, or my group, the Courier Group, does. And the fact that we're actually quite a huge Scala community, but inside a very multilingual, multi-technology company. So I just want to set the scene a bit because I'm going to tell you a bit about how we build services, but we also have to use a lot of common infrastructure. We're broken up into 8 autonomous groups. We are completely on Amazon Web Services. We use centrally managed Kubernetes clusters. I mean, what that means is basically I get to build Scala services, hook them up to a bunch of magic, very scalable things, and then send them into the ether, and they automatically get auto-scaled for me, which I think is great. Each group can essentially choose their own tech stack. So this is also why, if you're wondering how do you get Scala at your company, why do we use Scala, it's basically because some people at some point wanted to use Scala and we get to choose and use whatever we want. At the same time, actually, you can see there's also Python and Kotlin inside Scala because functional programmers are the most opinionated people in the world. We do have a very genial discussion about whether to use cats or ZIO for our effects now, which I'll get into a bit, but obviously I'm on Team ZIO, so that's what I'm going to tell you about. So the story of how I'm going to show you our pattern is we basically started off in the Courier Group. We have a quite large monolith. This is also written in Scala. It's gone through a couple iterations of using Scala libraries. At one point it used the Play framework, so that's probably something that many of you are familiar with. We no longer use it, or we're trying to get away from it. Those people are very much team Cats Effect. But anyway, that's a very big code base. My team actually, what we try to do is build very small, simple services outside of this monolith. That's because we were adding new features. I don't want to get too much into more of the business, but we basically get to build lots of very small features in kind of greenfield development. So we get to also choose our own tech stack, even inside a group that chooses their own tech stack. So that was, maybe why do we choose ZIO? Why do we build things the way we do? Well, so we have a really common pattern to how we do this, and some of this is because our company is organized this way, which is we consume a lot of data via Kafka. This is because whether you want to call it event sourcing or stream processing, we send a lot of messages on Kafka clusters. That's how we get data. We don't make a lot of synchronous API calls to one another. So one of the things is anytime we want to make something, we want to add a new feature, there's going to be some Kafka consumers involved. The next thing is that we tend to, in my team, we have a very common pattern. We basically read a bunch of data, we want to sort it by these couriers' IDs, and we want to represent it for our own front-end APIs. So once you start seeing this, you can start to see, okay, there's a nice blueprint for these kinds of things where there's, on one side, you have very nice consumers that are going to maybe transform or enrich some data, but then they want to write it super fast into a database. Despite only having, maybe I said 230,000 couriers, some of the data is quite high volume. The big example I will use is location updates. Anytime you're looking at your app and wondering, like, where's my courier? I mean, those have to be ingested by someone. Among other teams, we ingest them. And then we want to present it to our front end. So that for that, we want to use HTTP APIs. So again, this is also because I like to promote ZIO has very good integrations with many of these tools. This is why we use them. We use Kafka, we use DynamoDB, sometimes Postgres, but DynamoDB because we're a big write by key, read by key kind of systems. We use Redis for caching. We use monitoring in Datadog. And then we use ZIO for our services. And again, this is not without controversy. I'm going to just take a brief second. Does everyone know what ZIO is? I can just skip this slide. Or I guess I don't know. Does anyone not know what ZIO is and wants to have a brief view? No. OK. You would like it. Great. So ZIO is it's an effect and asynchronous programming library. So we all love these. I mean, in Scala, you have everything from futures to I/O to what Oleg is presenting is maybe the future. So ZIO is one of these that uses a monad abstraction to do asynchronous programming, basically. And maybe compared to other I/O frameworks, it does try to hide a bit of the monadness from you. So it basically has one type that you see over and over again, which is this ZIO, and then it has 3 type parameters. So what is this? This is basically a monad that has an environment. It returns either an error type or a success type. And if you're very quick, you'll notice this looks a lot like an IO either type. It's very similar to that. The sort of magic of ZIO, or the simplicity, is it tries to shove everything through that, which I think is great. It's very accessible for maybe new people who are not used to these libraries. Whereas the moment they see something like cats, and they might see a lot of different possible ways that you can abstract things. They see monad, they see functor. I know for everyone here, these are very easy words now, but sometimes they're not for people who are just coming up to speed with these libraries. They have their own way of modeling concurrency. They use these things called fibers. These are basically green threads. I think this is also very common in almost all of these libraries these days. No one tries to use one-to-one with OS threads. You end up killing your system really fast. One of the magics of ZIO that I'll go into is they use this concept of layers. It's basically a way of managing dependency injection. You can take a regular class, you can lift it if you want to an asynchronous process, and you can wire them all up automatically. And that's, like, I would say, the magic for us of why this is so simple to use. I don't know what I've done. OK, it's OK. So just to give you why ZIO, if you want, this is me with my boss. So he said it's because ZIO seemed easier. I said, well, I will just screenshot what you said and end my talk to screams and chair throwing, because usually no one at a meetup for a functional programming language likes to hear like ease of concepts as a reason to use something. But it does make things easier. I will also say, purely from a code, maybe aesthetics perspective, you don't end up with any monad transformers anywhere because you're basically forced to use one. And then the other, I would say, really easy thing is the dependency injection. If you're building a lot of services, if you've used something like Spring in the past in your life, you might want to throw your chair out the window just from trying to get the dependency injection to work. So I'll show you a little bit, but this happens at compile time. Actually, the types tell you what you're going to dependency inject or not, and this is very easy to manage a lot of different services with a lot of different shared code in ZIO. And finally, this is a bit more of a pragmatic, but it has really great integrations to the services we use. That's why I listed all of those. So out of the box, it's very easy to use Kafka. It's very easy to use DynamoDB or the DB of your choice. So again, if you're looking at trying to get Scala into your company, or people are a bit skeptical, this is a very pragmatic solution to be able to very easily get going with probably whatever you already are using at your company. So just to outline a bit how we build, this is the structure, I would say, of a basic service of ours. So all of the colored parts are what we would call ZIO layers. So there's basically a class that gets wired up asynchronously with other classes. And all the white stuff is either code or infrastructure. So the nice thing is you can see we just have a bunch of APIs at the top. This is what you would call the read side, where people actually get to see the data. The consumer is here on the left side. And then they get to share a bunch of code, which relates to how they read and write to our data stores. And then we do leverage, even among these different services, we do leverage some shared code. That's, I would say, mostly related to how you want to access, beyond the ZIO integration, some abstractions to talk to some Amazon services. I know not everyone memorizes the icons, so these are for Postgres, Dynamo, and for Redis. So just to get a little code in here as well, so if you're wondering what it looks like, so I basically have a regular class, let's say. So this is an API. This presents a bunch of HTTP endpoints. It takes this thing called the service, which, I mean, it basically is a way of accessing data and getting some transformations from the data layer into your application layer. What's nice is, so I want to convert this into a layer. I mentioned layers as a way of doing dependency injection. So you can get a hint to what happens is, by lifting this using this from function, what I get is, I get a type signature that says, this is going to be what I want to be basically an asynchronous process. It needs things of this type. This is the errors this is all the errors it will possibly produce. And at the end, it will produce one of these things. I think the real magic for me here that has made this really easy from a usability perspective is these union type signatures. So this really automatically tells the compiler, hey, this thing needs these things. And that sounds trivial, but it's very nice later on. So why? So when you start looking, hey, I have a program I want to run. This is a pretty typical for comprehension. What happens when you actually compile this is that this program deduces, hey, I need a bunch of things in my environment. I mentioned this environment type before. And there you can see this is where the type resolution takes care of your dependency injection. It takes all these union types and actually does a type check to say, have you provided me with something that provides all the types my program needs? And have you provided something that all of those dependencies need? The beautiful thing for me is you actually, at the end of the day, if you mess up, which I mess up all the time, you immediately get a very clear error message. Hey, you're missing something, and it's of this type. And maybe that sounds really trivial if you're writing really small things or if you wrote everything from scratch, but when you start messing with someone else's code or you're moving around code or you're trying to get someone else's layers in here and you don't really understand why things are not working, this is super key to, I think, having really nice productivity when you share these code bases. So then if you want to get a little bit into what this actually becomes when you deploy it, so we are on Kubernetes, so you get a bunch of, well, not a bunch, in this case, you get 2 services roughly in this kind of format. This is one way that we have modeled our services before. You actually see all of this code, but what this really gets deployed to is 2 containers. So one container, in this case, was on the right side or intake side, and you can say here, this was really easy in the style I just showed before. It's quite easy to just put a bunch of layers in that say, hey, I have some consumers, and you'll even tell me if I miss them, but here are all of the things you need to write to them. And this becomes a complete app that just gets started, and it's very easy to deploy. On the same side, I have a completely separate app, but I want to share these like accesses to the data, but I want to be able to read it instead. So instead, I just put the API, and then at the same time, I get all the services. That sounds pretty trivial right now, but I'll say actually, we started with this model, and then these boxes are a bit, we actually had about 5, 6, 7, 8, 9, 10 of these, and having so many consumers on one machine is not very good. Likewise with the APIs, they were just starting to get a bit monolithic each on themselves. So the next thing we wanted to do was break them up into what we would say is like, you want the consumer and the API on one machine for one kind of service, the consumer and API on another machine or container for the next one. And actually migrating between these, I think without this layered system of compile time dependency injection would have been quite error prone. It would have been quite annoying, and I don't think we would have organized our code nearly as well to begin with to make this transition super easy. And it actually was done with no deployment time problems, despite moving around quite a lot of configurations, moving around a lot of code between a lot of different repositories. So now what you have here, you can see the kind of nice part is each API layer. So before we went to, if you want to see real quick, we had consumers and APIs, and then shared code, which was access to the data, which was access to their data. In this case, each one has its respective consumer and API. So these are the sort of things you seed the program with. You say, hey, I want to have an API into consumer of this kind. The compiler will tell you, well, then these are the different things, these are the different services and repositories you're going to need. So if you miss out on them, you will instantly get a really nice error message that tells you exactly what it is and exactly why. So that's my selling point of the reason I love ZIO so much. I will say we really do love layers. So the compile time checks have been really nice to use. I would say this encourages a kind of code organization that maybe seems very obvious now that we've done it, but I think it's actually something that it really just makes it really easy to think of all of your code as classes, and then the asynchronous part comes for free, and it's really easy to move them around between different services. Definitely, we've had people join who are less experienced Scala developers, or who are Scala developers who have used only features and never used effect systems before. And this is really, really accessible to them. I can say I have worked at places that have used cats. And this is only an anecdote, but they have people who have never seen effect systems before, and they get into cats. It's not easy for them to come into. Sorry, cats fans. Sorry for half of my company who uses cats, but it's just true, I think. This also provides us with a lot more. We don't use it right now, but a lot more opportunities for abstraction. So you can see now we already have a bunch of layers of different services, repositories. Those actually don't share any code. So every time we write access to one kind of database or table, we write it from the beginning, but we really ought to share a lot of that information, a lot of that code, especially with respect to logging and error handling. That has ended up being copied and pasted around a whole lot. But we could really, really reduce the amount of code we have even more today. Performance-wise, so I think this is when I talk about scale. So we haven't had any performance problems yet. I think that's quite good in the sense that we have very peaky traffic. We are mostly present in Europe. During the night, not a lot happens. During the morning, you get during the daytime in Europe, you get a lot of traffic. During peak times, during holidays, you get a lot of traffic. I mean, between being able to use Amazon services, but also due to the fact that you sort of get all of this concurrency for free with nice fibers. Everything just runs so far. We haven't had any problems where things have lagged weirdly. And I think that's pretty nice. That's not an experience I usually get. This is the part that has maybe been an issue, and I think this is maybe an interesting issue about these effect frameworks in general, is they don't mix with each other nicely at all. So we're really happy using ZIO, and we also have people really happy using Cat's effect. And this is what happens when we try to sort of play nicely with each other. Also, just so when you notice, the moment you put cats into an AI image generator, it just puts cats everywhere. Just like the rest of the internet just really loves cats. But yeah, we're actually trying to figure out right now how to make them work together. And what I mean by work together is not so much I want to use cats and ZIO in the same service. I think what we're really missing out on as a community, and this may be even true of Scala in general, is, for example, our Kotlin community. They have really come together to build templates, to build really fast services. They have a lot of really shared abstractions over infrastructure. When the infra team wants to get them to use our infrastructure in a different way, they have one place to go, one group of people to talk to, and they make these changes. That is not the case right now with the Scala community. So in addition to saying, hey, what do you guys use? And we give them a bunch of answers to frameworks, then they say, okay, now which ones are you going to build out? They don't really have a good answer. Or how do we actually get you guys to, build libraries we can make easy changes to? We don't have a good answer. So there are kind of a couple options. We haven't really worked them out. I mean, write everything twice is very tempting. I think also functional programmers really love writing their own integrations to everything, but I think this is not a very realistic way to go forward. The next thing is, of course, to fight it out. Unfortunately, we're both pretty deep in this game now. So our biggest monolith, which makes us a lot of money, is in cats. And my team at least has 5, I think maybe up to 10 plus services now written in ZIO. So we're kind of playing chicken if we're really going to think one of us is going to win. And now my colleague is taking a photo of me. I'm really worried about that. And then there's this kind of way that, we're trying to work it out, but we'll see what happens, is to write as much shared code as possible, say outside of the effects framework in this tagless final way. I think most people here are aware of what tagless final is, but this is basically, you end up with a functor f everywhere that you have to actually instantiate at the time. It's kind of an open question if you can achieve a decent abstraction and actually still implement any decent business logic this way when you're trying to go between effects frameworks. So because at the end of the day, I mean, I've just talked endlessly about ZIO layers. This is something very idiomatic to ZIO. It would be quite hard to also have that kind of thing, be able to express this kind of idea idiomatically in ZIO and have the same thing in CATS. So there is a question at what level can you actually have this shared code, and at what point are you going to have to write everything twice? But in the meantime, we're pretty happy. And that's pretty much the end of my talk. If you have any questions, feel free. Also, I've been asked to put this QR code if you would like to come work with us. Even though we have holy wars, we're really nice. Yeah, that's it.
Yeah, Thomas Harper, everybody. Let's give him a hand. I think I actually have a solution for your dilemma. Yeah, you just rewrite everything in direct style. Yeah, so no one's happy. No. At least then it's fair. Okay, so we've reached the end of our regular programming. Oh, sorry, yeah, questions. Does anyone have any questions? Oh, go ahead.
Pardon?
If the Kotlin team is also into functional programming.
So I'm being recorded, and I don't want to say much because I haven't seen too much of the Kotlin code. I know a lot of them have gone full in on Spring Boot, and I wouldn't say that yeah, that face. So I would say I haven't seen a lot of it. I haven't seen, I wouldn't say a lot of our Kotlin code. Like I said, my entire group is all Scala at the moment, which I love and don't want to change, whether it's cats or not. But yeah, no, there's a large portion of Spring Boot people. Anything else?
Okay, so yeah, that concludes all the talks. We still have